Hello, I'm Sosa Prasad, and for this assignment, I have built a professional e-commerce image auditor. My system doesn't just guess if an image is good, it extracts verifiable technical signals using YOLO for object detection and OpenCV for heuristic analysis. Before using DeepSeek Carbon, which is the LLM model I am using for this assignment. Uh, as you can see from our first test case, the system has identified a chair which was in the image, and for this detection I used YOLO model, and for this use case I haven't trained any YOLO model specifically. And coming to why I am using YOLO model instead of using direct the LLM model. So because it is explicitly specified in the assignment instructions that I shouldn't use the LLM model directly. Instead, I need to send the features of the image instead of sending the image directly. So as you can see, using OpenCV, I extracted some signals which are sharpness and object sharpness, and is the subject focused or not. So basically what are these arguments is, so global sharpness is the blur of the sharpness of the entire image, which was normalized between 0 to 1. And for this specific image, the sharpness score is 0.73, which means it is a sharp high quality image. So, and for the and about the object sharpness, uh, it is 0.59, which means for this specific chair object, the sharpness score is 0.59, which is a decent score because the object isn't focused. So using these parameters, we were sending these parameters to the LLM model. So why? Why? Because this is a crucial distinction. So it tells the auditor, which is our LLM model, that the background is actually sharper than the product itself. So this allows the LLM model to conclude that this isn't any bokeh effect, but rather than a technical failure in focusing in the subject. Because uh, focused image are widely used in e-commerce websites rather than a unfocused image. So which means this isn't any what are the most influential signals that affect our LLM decision making? So the key features which affect our LLM decision making are the object coverage and the brightness score. So basically, object coverage in the sense, in the entire image, how much area how much area or how many pixels does our object or product occupied in the entire image. And brightness score is uh, whether the image is bright or dark in that way. Uh, these scores are also normalized between 0 to 1. So the brightness score is 0.24, which is an okayish score because the more the brightness score, the brighter the image. But we don't prefer much brighter image or much darker image. So this score is pretty much acceptable. And despite being low quality, being labeled as good, so lighting quality is good, which means this image is pretty much usable for a e-commerce website. So these signals allow the LLM to provide highly actionable feedback, such as guessing the user zoom in or increase exposure rather than giving any generic bad image error. So coming to the part 4, so whereas my decision making, why I used this specific use case. So So here I'm prioritizing the signal over noise. So what are the signal variables in the sense? So object coverage, brightness score, and sharpness of the image, sharpness of the object, and content score and detected objects. So I have created an auditor that provides explainable results. We aren't just relying on LLM's vibe or any randomness. So we are feeding it with the deterministic mathematical values that we calculated using YOLO and OpenCV. So this structured approach ensures that every rejection has a clear and data-driven reason that can be communicated back to the vendor. So, for example, for this specific test, so the LLM we sent this JSON object to the LLM model to give our reasoning. So the output, which is reasoning, the LLM model giving us is that the image contains a chair with moderate confidence. However, the object coverage is low, suggesting that the chair is not the dominant element, which is pretty much okay. And the brightness score indicates the poor exposure. So as we discussed earlier, so this has okayish brightness score, which despite being good quality image, object sharpness is 0.59 and lack of subject focus further reduce the image quality. So these technical issues could negatively impact product appeal. And the confidence score here is the how much our LLM is confident with its decision making. And these are the improvements that are suggested by our model by the LLM. So increase the object coverage by adjusting the camera position or zoom. So improve brightness and exposure to ensure proper lighting. Enhance sharpness through better focusing or post processing. So by increasing the sharpness, we will increase the quality of the image, thus improving the appeal for that image. So, and the final suggestion is that ensure the subject is properly focused to highlight product details. So that's it about this project. And if you want to try this specific model, so you can just head over to my GitHub repo, which I will add the link along with the video. So you can just clone this repository and run it in your system. So and I forgot to mention the requirements for this specific project is that LangChain and LangChain Olama. So why Olama is because I'm not using any OpenAI API keys. So I have Olama installed in my system. So I'm using DeepSeek R1 in 8 billion parameter model. So in that way, so I can save cost by running the model in my local system and Streamlit for creating web UI and OpenCV for extracting the signals from the image. And Ultralytics is the core package which contains the YOLO modules. So that's it.